Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Richard Seeley. Please go ahead, sir.
Hello and welcome to today's webcast, 10 Deadly Sins of Agile Software Estimation, sponsored by Construx. I'm Rich Seeley with adtmag.com. Thank you all for joining us. Before we begin, let me take care of a couple of housekeeping details. Please feel free to type your questions into the Ask a Question box on the console at any time during the presentation. We will address as many of your questions as we can during the live event. This webcast is being recorded and will be archived for future viewing. We will send you an email when the replay is available in approximately 24 to 48 hours. You can access the replay using the same link you used today. And now I'd like to introduce today's presenter, Steve McConnell, CEO and Chief Software Engineer at Construx Software. Steve consults to a broad range of industries, teaches seminars, and oversees Construx software development practices. Steve is best known as the author of Code Complete, which is considered by many to be the best software development book of all time. Readers of Software Development magazine named Steve one of the 3 most influential people in the software industry, along with Bill Gates and Linus Torvalds. In addition to Code Complete, Steve is the author of Software Estimator, Professional Software Development, Rapid Development, and other titles. His books have won numerous awards for Best Software Development Book of the Year. His most recent project is an ongoing lecture series called Understanding Software Projects. Steve is making these lectures available to those who have registered free for the next 90 days and will send you an email to access them. It's always an honor to have Steve with us, so welcome, Steve, and please take it away.
Thank you, Rich. Thank you for the very nice introduction. It's a pleasure to be here this morning to talk about 10 Deadly Sins of Agile Estimation, and thanks for joining me to talk about this very interesting topic. I have given talks on deadly sins of estimation for quite a long time now, but I think that the Agile practices really have changed the landscape some, and so this talk really is going to be a little bit different from what I may have talked about in the past in terms of deadly sins of estimation. The background is still kind of similar. I wrote an estimation book quite a while ago. I actually signed a contract for that book. And then a lot of life events intervened, and it took me 8 years to get that book out, and that was a long time. I had that project in the back of my mind and was working on it for quite a while. But the good news there is I actually got a lot more experience with clients, and some interesting research came out, so I think that all actually helped the book that finally came out. My company has made a software tool available for a long time. This tool is honestly quite out of date at this point. We have not updated the tool in more than 10 years, but at the time we actually learned some really good estimation lessons through the production of that tool, and then feedback we got on the tool and watching companies try to implement the tool. So there were some good learnings there as well. And then, of course, my company Construx has worked with hundreds of clients in the consulting and training lines of our business over the years, and so we have learned all kinds of lessons through that, both really through consulting and training. We actually learned a surprising amount through the training part of our business, and you know, it's a kind of a aphorism, but it really is true that we learn as much from the companies we teach as we teach them. So this is the background that feeds into the 10 Deadly Sins of Agile Estimation. Now, of course, one of the problems when you go to construct a list of 10 deadly sins of Agile estimation is limiting yourself to only 10 deadly sins. There are so many things that can go wrong. And so I'd like to start by introducing the almost deadly sins of Agile software estimation, so sins number 20 through number 11. Sin number 20 would have to be telling someone you're writing an estimation book, because they always say, when do you estimate you'll be done with that? Ha ha ha. And that joke gets really old after 8 years. Sin number 19, assuming the sales department is better at estimating software projects than the programmers are. kind of an oldie but a goodie. Almost deadly sin number 18, presenting estimates with a high degree of precision, such as 67.4 days, but that are supported by only a low degree of accuracy, plus or minus 2 months. Sometimes technical staff will complain that when they present estimates to their business partners like this, that the business partners will pay attention to the nominal number, but they will ignore the plus or minus part. And I think actually what's going on there is that we're presenting a mixed message. The message of the precision of 67.4 days says we know exactly what we're talking about, but the qualifier of plus or minus 2 months says we don't have any idea what we're talking about. And if the business partners want us to know what we're talking about, then they're going to take the half of that message that they like, which is the high precision part of the message, and ignore the part they don't like. It really is on us for presenting that mixed message. Almost deadly sin number 17 is creating an estimate for a new project by using historical velocity data from a different team. This is something that we certainly have seen companies doing as they've moved into use of story points and velocity for calculating release burn downs. And we have yet to see a really good solution about reconciling velocities across different teams or when staffs change and that kind of thing. Almost deadly sin number 16, rationalizing a velocity number that's lower than you wanted by saying, well, we were climbing a learning curve with new tools and learning a new business domain. We won't be doing that the rest of the project, and so our velocity will increase. This is a rationalization that has been in play for a really long time in different guises. The problem, there's a truth here. We were climbing a learning curve with new tools, and we were learning a new business domain. But the issue is we're not going to speed up as we learn all the lessons from that. We're going to slow down because of all the mistakes we made when we were climbing the learning curve and learning new business domain. We're going to end up either keeping velocity the same or even maybe slowing down because we have to correct all the mistakes we made early in the project when we didn't really know what we were doing. Almost deadly sin number 15 is estimating what you'll be doing on May 22nd, 2018 when you don't even know what project you're working on as of July 2017. And this is basically a confusion about what the word estimating even means, and we'll talk about that a little bit more on one of the actual deadly sins. Almost deadly sin number 14, trying to remove uncertainty from the project by removing uncertainty from the estimate. And I think the fallacy there speaks for itself. Almost deadly sin number 13, trying to remove uncertainty from the project by calling the project Agile. Agile has lots of strengths. It does not have a magical ability to remove uncertainty just by applying it as a label. Almost deadly sin number 12, thinking that your Agile team isn't estimating because it's, quote, forecasting. This is one of the more, I think, annoying developments that I've seen in recent years as teams actually apply estimation practices and say, we're not estimating, we're forecasting, seemingly oblivious to the fact that forecasting is a specific kind of estimation. Specifically, a forecast is an estimate that has to do with estimating something that's going to occur in the future. So if you're estimating the number of fish in a lake, that's not forecasting because those are the fish that are already there. If you're estimating how many fish are going to be in the lake next year, that would be forecasting because that has to do with the future. But forecasting is a particular kind of estimation. It also happens to be the kind of estimation we're primarily concerned about when we talk about software estimation. And then almost deadly sin number 11, thinking you want an estimate when what you really want is control. And I think this is a confusion in the part of project sponsors or project managers, sometimes team members, but really it comes down to what does the term Agile mean to you? Does it mean that you really do want to be flexible and responsive and give up on predictability altogether? Or does it mean that you want to use practices that can give you some flexibility and responsiveness, but that also support really good predictability, and you still want that predictability too? Getting clear about that is something that we will come back to a little bit later in the talk as well. Well, with the almost deadly sins under our belts, let's go ahead and talk now about the deadly sins of Agile estimation. And I think the first one that we have to start with, deadly sin number 1, is believing that good estimates are impossible. And this is highly problematic. If we believe that good estimates are impossible, or if we believe anything is impossible, we won't try to do it at all. I mean, why would we want to do something that we believe is impossible? That would be an irrational thing to try to do. And so if an individual or team actually believes that estimation is impossible or good estimates are impossible, they're not even going to try to estimate. Even if we compel them to estimate, they're going to do it half-heartedly. Further, if you believe something's impossible, you're not very well going to try to develop skill in it so that you can do it better. And so I think this belief ends up being tremendously damaging to our ability to create good estimates. And I would say, that while I find this belief to be ultimately unfounded, there's no basis for it whatsoever. We see lots of organizations estimating poorly, so if someone wants evidence that estimation is often not done well, there's plenty of that evidence out there. In fact, many people can work in the software field for many years in numerous organizations and never see estimation done well. The fact of the matter is that in software development, average practice is a lot closer to worst practice than it is to best practice. The distribution of skill in software is not a bell curve where average practice is right in the middle. In software, average practice is really skewed far to the left in terms of being closer to the worst practice than the best. So you can work for a long time for multiple companies and never see estimation done very well. And from my point of view, good estimation is not all that difficult. It's not all that time-consuming. But it's not all that intuitive either, which is to say, even if you are a reasonably smart person or a very smart person, trying to intuit good estimation practices from first principles is going to be an error-prone exercise. And while it's not difficult when you know what you're doing, it's difficult to figure out what you should be doing and to do that without really piggybacking on the shoulders of people who have been looking at these questions for a really long time. We've had a lot of really smart people looking at the software estimation topic for decades. There have been a lot of good developments over those years. There have been a lot of dead ends that have been discovered to be dead ends. So this is definitely a field where learning from other people who have already been here and been working in the area is really an important thing to do. There's interesting research on expert estimation, which is that when organizations have someone create estimates, they typically don't assign people who are experts in estimation. It's much more common for them to assign people who are subject matter experts. And I think this is a natural assumption that the person who knows the subject the best would also be the best to estimate it well. But what we found is that even people who have high expertise in the subject they're estimating tend to use simple, or I would say primitive, estimation strategies even when their subject matter expertise is high. And so while they might know a lot about the subject, they don't necessarily know very much at all about estimation, and so the estimates end up being poor, not due to a lack of subject matter expertise, but due to a lack of estimation skill. So what we end up with, the bottom line, is that we typically see terrible estimation practices applied with equally terrible results. And this is really unfortunate because if we get some training and if we can put some organizational support behind it, my company has found that when we supply appropriate training and get some data collection in place, the organizations we've worked with have achieved estimation accuracies of 90 to 100%, meaning that they end up delivering 90 to 100% of their projects on time, on budget, with intended functionality. And for people who have never seen an organization that estimates well, I think that's almost like impossible to conceive because their projects are routinely overrunning by a factor of 2 or they have no control whatsoever. But once we get some good practices in place, the potential here really is very, very good. All right, deadly sin of Agile estimation number 2, confusing estimates with plans. And this is something that really came out of the no estimates movements, at least that's where I saw it. I think this is really an unfortunate attempt to indict estimation because it just confuses the terms. And so the basic argument goes something like this, that trying to estimate a software project is like trying to estimate a game of chess. It can't be done. And if you don't think about it very hard, there's a certain intuitive appeal to that line of reasoning. Oh yeah, how would I estimate a game of chess? But really what we're doing when we make this claim is we're confusing estimation and planning. And the distinction I find most useful here is to say that planning is about how, and estimation is about how much. The chess game example is really more about planning and not so much about estimation, because when people say we can't estimate a chess game, what they're really saying is we can't estimate exactly where the pieces will be on the board at any particular time, or exactly what move somebody is going to make when they get to move 17 in the game, but that's really a lot more about planning, about how, than about how much. And there actually are all kinds of ways that I can estimate a chess game. I can estimate how long a game will take. I can collect data on large numbers of games of chess that people play, and I can compute what the average length of the game is. I can compute what the standard deviation is around the lengths of those games. I can come up with confidence intervals that say I have a 90% chance of being done by a certain amount of time based on historical data. And I can do the same thing with counting the number of moves that will be needed in a chess game. I can collect data on large numbers of games and how many moves are needed on average, and compute standard deviations and confidence intervals and all that kind of stuff. And the interesting thing about this is a lot of people who aren't very knowledgeable about estimation assume it would be harder to estimate a series of games than it is to estimate one game. But actually, from a mathematical point of view, it's actually easier to estimate how long a series of games will take than it is to estimate how long an individual game will take. With an individual game, there's always going to be that variation, and we don't know in the individual case whether that game is going to be exactly average or whether it's going to be one standard deviation longer or two standard deviations longer. But if we have 20 games and we're estimating how long the total of those 20 games is going to come out to be, we can actually be pretty confident that it's going to come out to pretty darn close to 20 times the average length of the games that we have observed in the past. So there's some interesting misconceptions here about the difference between estimation and planning, some interesting misconceptions about what we can do with a group of things versus individual collection of, or an individual instance of things. In Agile estimation, one of the places this comes up is in the difference between, say, release planning and sprint planning. We are looking at more stories or more features when we're doing release planning, and given the historical data we actually have a greater ability to predict the release with accuracy than we do to predict the sprint with accuracy, just because we have more things showing up, a higher quantity of things showing up in the release than we do in the sprint. So given the higher numbers, we actually have a better ability to make that longer range, bigger estimate than we do to make the shorter range estimate. And that actually implies use of some different estimation practices for, say, sprint planning, which is really internal to the team in Scrum, versus release planning, which is going to be something that would be kind of a combination of internal teamwork but also externally visible to business stakeholders in the organization. Deadly sin of Agile estimation number 3 is confusing estimates with targets. So we have one confusion of estimates with plans. We also have a confusion of estimates with targets. And here I think what we see in the software industry is the software industry does an awful lot of target setting. We tend to have business stakeholders that say something like, we have an important business reason to be done by a particular date. Therefore, we estimate it will be done by a particular date. Well, the target setting is an entirely legitimate activity, but what's not legitimate is to take that statement of a desired end state and to treat that somehow as an estimate. If those targets are not created through observations of productivity of the team or the organization or analysis of the actual work to be performed, then they aren't really estimates. They actually are an articulation of a desired end state or a target. And I think what we still see in practice is we still see a lot of businesses that really aren't doing much work that you could actually call estimation. We see businesses that define targets and then treat those targets as estimates or hand them to the team and say, here is your estimate, and then the teams are kind of stuck. Or the teams think that they're kind of stuck. And I think one of the things I've been working on for 20 years now is trying to work with teams to help them clarify when their business is giving them a target versus when the business is asking them for an estimate. And the response from the technical staff really needs to be different depending on whether the business is giving you a target or asking you for an estimate. Target setting is a completely legitimate business function, but what's not legitimate is assuming that the fact that you can describe a target makes it possible to achieve the target. We can describe all kinds of targets. We can say, I want infinite functionality by next Tuesday. That does not mean it's possible to actually deliver to that target. And so part of target setting is defining the kind of ideal state target, but then part of target setting is, in fact, a supporting estimation activity that helps us understand how achievable is that target. And if the estimation activity says that target's not going to be achievable, then we need to do some iterative discussions with the business to figure out, well, what can we achieve and how should we revise our target, or is it even a good business idea to aim for this target. Maybe if there's too much of a gap between the estimate and the target, we just should regroup and aim at some completely different target, which is to say not do that particular project. I think technical teams often shoot themselves in the foot by being in a situation where the business is actually asking them to figure out a plan to meet a target, but instead responding with an estimate that says this target's impossible. And sometimes the business uses its terminology pretty imprecisely. They will actually say, they will say, we really need to have this functionality ready for this trade show in July. Can you estimate how long it will take to get this functionality ready? Really, there's a mixed message there. On the one hand, they're saying we need to have this functionality ready by July. On the other hand, they're saying, can you estimate how long it will take, which might not be by July. And so on the technical staff side, we actually need to recognize that there's a potential contradiction in what that message says, and we need to actually ask. We need to say things like, okay, so I hear you saying two things. One is we need to have this ready by July, and two is how long will all this stuff really take? So if we come back and say, hey, if we have to do all this stuff, it's going to take us into October, do you want us to come back and say that? Or do you want us to say, come back with a plan to get as much done as we can by July? You know, what is the real assignment here? And typically the response from the business at that point will be to say, well, we need everything by July. I think you can just expect that's going to be the response. But after you give them a chance to say that, then you can say, okay, we realize that that's a desirable outcome. But let's just say, it turns out that that can't happen. What really is the objective here? And at that point, if they say, well, we really do have to have something ready to show at the trade show by July, then it's pretty clear the mission is figure out a plan to meet a target. And that goes back to the almost deadly sin of, are you really talking about estimation, or are you talking about some kind of planning and control? And in that dialogue, the business might have started out talking about estimation, but really, when you dig into it, you find they're asking for you to engage in some kind of planning and control. Deadly sin number 4 is misunderstanding or misapplying the cone of uncertainty. And the cone of uncertainty is something I've been writing about for 20 years now. And the cone of uncertainty basically says that in the early days of a software project, when you haven't really pinned down your functionality, you may not even have pinned down in general terms what your software project or product is all about, you're not going to get very good estimation accuracy at that point. And the reason for that doesn't really have all that much to do with estimation. It has to do with the fact that the product concept itself isn't pinned down, and so there's underlying variability in the project, and a good estimate is actually going to be one that accurately reflects that high degree of underlying variability in the project. And so even if you could estimate with perfect accuracy at initial marketing concept time or detailed marketing concept time, your estimate, your super accurate estimate would reflect a high level of variability because there's still a high level of variability in the concept of the thing that you're going to build, but you haven't actually defined in any detail yet. So part of the cone is the idea that in the early days of a project, it's not possible to have very good precision in terms of how long the project is going to take or how much effort it's going to require or how many features you can deliver for a given amount of time and effort. But what the cone also says is that if you play your cards right, working your way through the project, you can attack these sources of variability, you can buy down the variability, and fairly quickly you can reduce the variability from something like a factor of 4 plus or minus in the very early days of the project, so factor of 4 on the high side, factor of 4 on the low side, a 16x total variation. By about a third of the way into the project, if you are playing your cards right, you can reduce that factor of 16 variation down to about a factor of plus or minus 25%. And then at that point, you actually have pretty darn good predictability for the remainder of the project, certainly pretty good compared to the 16x variability that you started with. And then as we continue to work our way through the project, we have a potential for increasingly good estimates, increasingly low variability, and improving accuracy as we work our way through the project. So this is the basic idea about the cone of uncertainty. Now, one of the common misconceptions about the cone is that it is not just a prospect of improved accuracy, but a promise of improved accuracy, and that is just not the case. If the cone was a promise of improved estimation accuracy, then we would have all kinds of projects out there that start out with poor estimates, and they would all converge with highly accurate estimates, and we clearly know that that's not true. We have all kinds of projects out there that will start out with an estimate, and then they will think that they're getting close to being done, and they'll say, okay, well, we've only got 6 weeks left in our project, and they'll work for 6 weeks, and then they'll say, okay, now we have 6 more weeks left in our project, and they'll work for another 6 weeks, and then they'll go through that cycle again and again and again. I was associated with one project early in my career that thought it was going to release after 6 months, and it stayed 6 weeks from completion for the next year and a half. So it's pretty clear that the cone of uncertainty is not a guarantee of improved accuracy. It's more of a prospect than a promise, and it's easy project so that we get more of a cloud of uncertainty than a cone of uncertainty. And I would say literally hundreds or thousands of projects prove that every single day. We have all kinds of examples of projects running according to a cloud of uncertainty. And the reason for that is that the variability doesn't reduce itself. We actually have to take active steps to attack those sources of variability, to buy down the variability so that we can actually have a cone of uncertainty rather than a cloud of uncertainty. And so the cone of uncertainty is something we only get on a really well-run project. If we have a poorly run project, we are not going to get a cone of uncertainty. And so this is where the misunderstanding and misapplication of the cone comes from, is the expectation that all I have to do is let some time go by and my estimates will get better because time goes by and I'll be further into the project. That is just not the case. We do have to let time go by, but more importantly, we have to do certain kinds of work, specifically work that's aimed at attacking sources of variability, buying that down, and then that supports longer range predictability. So key points here really are it's not even theoretically possible to have a really specific estimate very early in the project. It is certainly possible to have a very specific target early in the project. It's possible to have.
And please stand by, everyone, as we try to get the line reestablished.
All right. So it sounds like we dropped the audio for a minute, and are we back on?
Yes, you are.
Okay, thank you. All right, so I will pick up with deadly sin number 5, and hopefully we got enough about the cone to get the idea across. Deadly sin number 5 is not estimating in enough detail, and I became exposed to this personally when I was working on my first book, Code Complete. I had been doing background research and outlining and so on this book for about 2 years before I got to the point where I was ready to submit a proposal to the publisher. And since I had never actually published a book before, I thought it might be a good idea to let the publisher, give the publisher some indication that I was actually capable of finishing the project. And so for the first time, I actually put together a detailed plan and kind of page-by-page estimate for the outline of the book. And in my mind, I'd been carrying around this idea that the book was around 250 pages. I didn't have any basis for that other than the fact that other books I'd read and liked were around that length. But in my mind, I was thinking 250 pages, maybe 300, but, you know, somewhere in that zone. And once I put together my detailed, decomposed estimate, my estimate ended up being 794 pages. And this was significantly out of alignment with my original notion I've been carrying around in my head. But this is very much the kind of thing that happens when you decompose a large chunk of work into smaller chunks of work, is you discover all the places that there's work that you just weren't thinking about because you didn't think about the problem hard enough. And so decomposing the estimate ends up being a good idea. In an Agile estimation context, this applies both to estimating whole Agile projects when we're very early in the cone. If we're not thinking about that whole Agile project very seriously or in much detail, then we can have the kind of error I had in my Code Complete estimate. It also happens when we're talking about estimation of epics, and I really don't like the idea of estimating chunks of work and story points above that scale that goes from roughly 1 to 13 story points. Once we get into stories that or epics that we're trying to estimate as 40 or 60 or 100 or whatever, I just don't think we're thinking about the work hard enough for there to be any validity to those numbers whatsoever. And if we do decompose those into smaller chunks, what we typically find is that they're going to expand into more work as we break them down than we thought they were when we were looking at them as one big aggregated thing. Another counterbalance to this idea is to use multiple techniques. And a lot of times what happens is if we're carrying around an idea in our head of how big an estimate for something is, and then we do an estimate one way, then we think, oh, that can't be right because it's so much bigger than my expectation, it must be wrong. And that, in fact, is what I did with my Code Complete project. I had my original 250-page estimate, and then I did my decomposed estimate of 794 pages, and I looked at that and said, there's no way I'm writing an 800-page book, maybe 300, maybe 350, but not 800. And so I decided to go and estimate it an entirely different way. And when I did that, I got an estimate of 751 pages. And given that there's only about a 6% difference between these two estimates, that actually gave me confidence that, in fact, I wasn't working on a 250-page book. I was working on something more like 750 to 800-page book. And the fact that I had two different techniques that I'd applied, and they both came out fairly similarly, really caused me to have to look at it harder. I couldn't just throw out the big number and say, oh, this is too big, it's not realistic. The multiple techniques made me really come to terms with that bigger number and the fact that I had a bigger project than I'd originally planned. And that allowed me to replan my project, reset my expectations, scale my efforts appropriately, and that ended up working out just fine. I think that a lot of the problem we see with people estimating is they're not very confident in their own estimates. And sometimes people will talk about trying to defend an estimate organizationally. One of the difficulties in defending an estimate is if you yourself don't actually believe in your own estimate, it's going to be tough to defend it. And so if you can increase confidence by using multiple techniques and see that they converge, that's going to improve your confidence in defending that estimate. Deadly sin number 6 is trying to use Agile estimation techniques too early in the cone of uncertainty. And this is kind of a key point, is that in the very wide part of the cone, we really don't have Agile estimation techniques even available. We don't have enough detail to do story points. We don't necessarily have an intact team at this point. The team hasn't done iterations, so we can't actually observe velocity during those iterations. And so in the wide part of the cone, interestingly enough, the estimation techniques that work best are the same, whether you're doing a Scrum project or whether you're doing a waterfall project, because we haven't really done the Agile work yet that lays the groundwork for being able to estimate in an Agile way. Once we are a little bit into the cone and we actually do have some detail in our product backlog, we actually do story point assignments and so on, well, now we can use Agile estimation techniques for most of the project, and they can work very, very well indeed from that point on. Deadly sin number 7 is estimating in too much detail too early in the project. So one of the sins is not estimating enough detail, but another sin is estimating in too much detail sooner than we really should. And so I think technical people who tend to be pretty analytical tend to think that more detail is always better. And from an estimation point of view, this is just not the case. Sometimes less detail is better, and that is certainly true when we're estimating early in the project in the wide part of the cone. And one of the common failures that we see of the slide says inexpert estimators, I'm trying to say non-expert or amateurish estimators, is doing too much work to get a worse estimate than they could actually get with less work. And we have seen this quite often with companies that are trying to do good things in the estimation space but don't really know what they're doing. And so if we're in the wide part of the cone, shown here highlighted by the yellowish shading, should a team use task-level decomposition at that point in the project? We fairly often see organizations that are trying to do a good job of estimation, trying to do task-level decomposition in those very early days of the project. This turns out to be highly problematic for a variety of reasons. One is you really don't know enough yet to know the details. That's what the cone of uncertainty is about. Those details are going to emerge as you do the detailed work of the project, but they haven't emerged yet in that far left side of the cone. The other problem is details are going to change later, and that's really one of the big drivers for Agile development in the first place is if the details aren't even pinned down, we really don't want to spend huge amounts of time looking at them. And another problem is if we're looking at task-level detail for an entire project, even if the project is, say, a 6-month project, that level of detail, to look at all of it at once, is overwhelming. And if those details are going to change, then we're going to have to re-estimate that overwhelming amount of detail again. And so the pattern we've seen with companies that are trying to do this is they'll estimate in great detail 6 months worth of work at the task level. They'll work for a month. The details will change. They'll re-estimate the next 5 months of work in great detail. It's an incredibly time-consuming process. And not only is it incredibly time-consuming, it doesn't actually work very well. And so this is really characteristic of an amateurish approach to estimation, which is doing way too much work to get an answer that actually isn't very good. And so what we found is that early in the project, algorithmic or macro approaches tend to work best. If we are doing Agile projects, particularly Scrum, then later in the project, estimates based on project data, i.e. velocity, can work best. Or if we're doing a non-Agile project, then bottom-up task-based estimates can work well too, but those are not done on a 6-month or 12-month planning horizon. Those are done on something more like a 30-day planning horizon, so that the level of detail is not so overwhelming. And depending on what kind of project we're on, how big the project is, where, what flavor of Agile it is or non-Agile it is, we're going to have different guidelines that apply to those different kinds of projects. Deadly sin number 8 is using only judgment-based techniques. And this is a long-standing issue. Certainly predates Agile, but has carried into Agile, which is just the belief that a gut feel could be a match for something that's a lot more quantitative, such as a release burn-down chart based on observed team velocity. And what we've seen in practice, and there have been numerous studies done over the years on this, including one done by my company a few years ago, is that the vast majority of estimates that are created in the field are created using so-called expert judgment. And the studies have found somewhere between 3/4 and 7/8 of project estimates are created using expert judgment. The problem here is that the expertise is expertise in something, but it's typically not expertise in estimation, and so those judgment-based estimates end up being not really very good, and I think the phrase expert judgment ends up being kind of a charitable description and not really accurate in terms of whether there's any actual expertise in the activity of estimation. This is problematic because what we end up with then is essentially experts who are experts in something giving what are effectively off-the-cuff estimates. And what we've seen is that the use of guessing and intuition, which is essentially an off-the-cuff estimate, to create estimates is correlated with cost and schedule overruns at a statistically significant level. So if you create an estimate for a project and you're doing it on the basis of intuition or guessing or gut feel off the cuff, then the project is probably going to overrun the estimate that you create that way. In contrast, interestingly enough, not all judgment is created equal. And we can improve judgment a lot by putting some structure around that judgment, and then we can improve it further by providing training in estimation. And the research on this point is quite interesting. What it has found is that with structure and training in estimation, then structured judgment-based estimates can be about as accurate as the estimates produced by complex algorithms and formulas. The research finding there is pretty specific. It's not saying that structured judgment estimates are more accurate. It's not saying they're less accurate. It's saying they're about as accurate as the estimates produced by complex algorithms and formulas. But when we look at what's involved in the training for estimation, and particularly when we look at what's really involved in putting some structure on that judgment, this goes into that category of practices that even really smart people are not going to intuit from first principles. It actually requires some training and some learning from other people in terms of what kind of structure is going to be beneficial. And that is going to have to be a topic for a different day. It's way too involved to go into in this short talk. The bottom line here is, while judgment can be good if we have the right kind of judgment, math is good too. And research has found that the use of even simple arithmetic formulas is negatively correlated with project overruns at a statistically significant level. And what this means is, that by simple arithmetic formulas, it means addition, subtraction, multiplication, division, and that's about it. And what that says really is that there's a world of difference between being in a meeting where your boss says, hey, can you give me an estimate for how long this project will take? And you say, oh, I don't really know. This is the first time I've heard about it in this meeting. And your boss says, oh, come on, we won't hold you to it, but you know more about this than anybody else does, so what's your best guess? If you actually reply to that with a number in that meeting, that is on the first category of intuition and off-the-cuff estimation, and your project is likely to overrun that estimate. Whereas if you say, hey, look, I really can't give you a number in this meeting, but if we need a number, I can go back to my desk, I can look at some notes from past projects, I can apply some simple arithmetic formulas, and 20 minutes from now I could come back and give you a number. That 20-minute estimate is going to be negatively correlated with project overruns. In other words, your project is probably not going to overrun that estimate. So a huge difference between an off-the-cuff estimate versus one that it actually involves even just a little bit of simple math. I would say further that if you can actually expose the math, even having some tool support behind it, whether it's a traditional software estimation tool or a release burn down that produces a graph like the one I started this segment with, there can be more credibility for that estimate. It might not be better founded than one that you do with paper and pencil and a calculator, but nice looking output can give you some more credibility as you go to present and defend that estimate, and sometimes that can be helpful too. Deadly sin number 9 is trying to estimate chaos rather than fix the chaos. One of the truisms of software estimation is you can't accurately estimate a chaotic process. The chaos is going to overwhelm whatever the estimate is, and the estimate's really not going to be worth anything. Typical forms of chaos that we see on Agile projects would include, a big one would be a meandering product concept. If we don't have some kind of road mapping that actually is done in a diligent way, that can lead to a lack of convergence toward a viable product, and then we get iterations that keep iterating, and they keep producing usable value, usable functionality with high business value, but it doesn't actually converge to anything that's useful in aggregate. So that would be one fairly common form of chaos on Agile projects. So not having meaningful project management still shows up a lot. No proactive or ongoing attention to quality. I think one of the most common failure modes we see on Scrum teams is not having that discipline of driving functionality to a potentially releasable level of quality, and as a result, a lot of defect correction work accumulates off-plan and off-schedule, and that's destabilizing. Tons of technical debt is kind of a variation on that theme. We still see lots and lots of low-fidelity Scrum implementations where people will say they're doing Scrum, but really what they're doing is daily stand-ups twice a week or something like that. So we still see lots and lots of chaos associated with Agile projects, and that becomes difficult or impossible to estimate when the project itself is so out of control. So bottom line here, kind of obviously, is if your problem is chaos, fix the chaos. There's always room to estimate better than you're estimating now, but the bang for the buck in this circumstance is going to be first fix the chaos and then worry about better estimation later. All right, the final deadly sin of Agile estimation is sin number 10, refusing to estimate because, quote, Agile projects don't estimate. And I think this is a painful one. What we see is that Agile, in particular Scrum, has a great ability to support flexibility and predictability at the same time. And I think because of the term Agile, which really the term itself speaks more to flexibility than predictability, Agile teams sometimes assume that their organizations value flexibility more than predictability. And in my experience, this assumption is usually unvalidated and it's usually wrong. In fact, I would refer to this as the great unvalidated assumption of Agile development is that organizations don't care about predictability anymore. What we have seen is that this assumption actually even leads to Agile and Scrum initiatives being shut down in cases because the business wants predictability and they want estimates, and they do want all the other good stuff from Agile, but they still want their predictability and estimates as well. When the Agile teams refuse to provide that, we've seen numerous cases where Agile goes away. And that is unfortunate because in a lot of those organizations, Scrum in particular would have been really beneficial, and the organization deprives itself of that because of something I see as a really accidental aspect of Agile development, which is this cultural tendency sometimes to refuse to estimate. And so what we see is that most businesses still need their Agile projects to estimate, and I think that we have seen the refusal to estimate damage Agile movement with senior business leadership. At the senior business leadership level, typically the idea that we don't need predictability just does not compute, and so it's a losing message from the start. I think for me, this deadly sin is a particularly painful deadly sin because it actually deprives us of something that Scrum specifically actually does really, really well. Scrum is capable of providing way better support for estimation than we ever had in the waterfall days. And so watching teams who actually are doing most of the work needed to support really good estimates and then kind of stopping on the 1 yard line and fumbling the ball and telling their organizations, we're not going to give you an estimate, is just really painful because they actually are in a position to, with a little bit more work, actually provide really good estimates if they just knew what to do. So, the strengths I see of Agile estimation, especially in Scrum, is that they are low effort compared to older waterfall techniques. If we are doing story pointing for our iteration planning, if we are collecting velocity information, we're doing 90% of the work that we need to actually estimate the release as well as estimating the individual sprint. Furthermore, that velocity data is actually, from an estimation point of view, the most powerful kind of historical data that exists for estimation. In general terms, it would be referred to as project data, but it's historical data from this particular group of people working on this particular assignment at this particular point in time, and that ends up being the best possible way to calibrate an estimate, and that is what velocity really is. Furthermore, because a well-run Scrum project is going to have short iterations, and if it's a high-fidelity Scrum implementation, is going to be driving to a potentially releasable level of quality at the end of each iteration, we get estimation data available early. After 2 or 3 iterations, we should have really reliable velocity information that we can then use out to project the rest of the project with high confidence. And for all these reasons, we actually have way more capability for Scrum estimates to be accurate than we ever got in the older waterfall days. And so it's just painful to me to see Scrum teams not taking advantage of all this great raw estimation material and actually using it to support better estimates in their organizations. So that really brings us to the end of my comments about the deadly sins of Agile software estimation. At this point, I will turn the mic back and see what kind of questions we have.
Well, thanks a lot, Steve. This has been great. One question that's come up is we have businesses changing so quickly on the business side of things. Are business users still looking for this kind of estimate?
Yeah, so I think the way I'd interpret that question is we certainly have seen a lot in the business press the last few years about Agile businesses, not just Agile software teams and Agile software development, but businesses becoming more Agile. I think that there's no question that is a current topic and lots of businesses are talking about it.
And please stand by, everyone. We did lose Steve's connection again.
So let's see. I'm not exactly sure at what point the audio dropped. Should I start over on the answer, or where were we?
I think maybe we could just go to another question. You had pretty much answered the one on how businesses were doing, although if you want to, how the business expectations might be changing. If you want to just summarize that before we move to another question, that might be good.
Yeah, sure. So I think the quick summary really is that, yes, businesses are looking for more agility, but the fallacy is that they want to give up predictability as they get more agility. They actually want both. And the good news there is I think Scrum in particular is capable of providing both.
Great. Now we've got another question on the 10 deadly sins. Which one do you feel is the most significant?
Yeah, that's a good question. I actually think I think there are 2 that are the most significant, and I think that the 2 that are most significant are probably the first one and the last one. The first one, that believing good estimates are impossible, is really damaging just because that basically undermines every other attempt to do anything in the area of estimation. And then, of course, the last one is damaging because that also essentially prevents us from even trying to estimate. So I'd have to say those are the two most problematic.
Okay, and then this is a sort of pessimistic question, but poor estimation seems like a long-standing problem. Does anybody really estimate all that well?
Yeah, so I tried to kind of address this a little bit during the talk by saying that the average practice is a lot closer to the worst practice than the best. Certainly, average estimation practice is poor, and there's no question about that. But like I said, we've worked with numerous companies that once they put a little bit of effort behind it and some training, then they've gotten to the point where they're delivering somewhere between 90 and 100% of their projects on time, on budget, with intended functionality. These are the exceptions rather than the rule, but it's not that they're the exceptions. Of the companies that have tried to do something, of the companies we've worked with that have actually really made an attempt to do this, they tend to do quite well. It's really the companies that don't even realize it's possible and don't put any effort behind it that are the ones that are stuck not estimating well.
Great. Another question is, what do you see as the key points or key thing that would make Scrum successful?
What is the key thing that would make Scrum successful? Well, I think from what we've seen with, we've worked with lots and lots of companies for quite a long time now in Scrum implementations, and I would say from what we've seen, by far the most common source of failed Scrum implementations is failing actually to do Scrum. In other words, low fidelity Scrum implementations. My favorite example is, it's often referred to as Scrum butt. And I think when there are more exceptions than actual following the Scrum practices, then that's quite problematic. My favorite example is a company we were talking to who said, well, we really like Scrum, but we found a lot of the practices wouldn't work in our environment. So the main Scrum practice we use is daily stand-ups, and we do those on Fridays. And basically they're not doing anything having to do with Scrum. They're just doing a once-a-week status meeting, and so they're not going to get much benefit from that. Scrum is an interesting set of practices because I really see it as already a minimalist set of practices. If I look at Scrum and say, what can I take away? There's not really anything I want to take away from the practices that are the core practices in Scrum. So when we see organizations that are supposedly not being successful with Scrum, but they're not actually using all the Scrum practices and they haven't ever had a good fidelity implementation of Scrum, first response has to be try to do a high fidelity Scrum implementation, and then we can take a look at whether that's working as well as it could, and we can start optimizing from there. But step number one has got to be try it by the book, and then we'll see if we can do it even better. But what we've seen is when organizations do try it by the book, they tend to get a lot of benefit.
Well, great. That's all the time we have for questions today. Thanks, Steve, for a great presentation. We appreciate you taking the time to share everything with us today. And we want to thank the audience for attending. The webcast, again, was sponsored by Construx and presented by adtmag.com. And for those who want to, again, listen to the webcast again or share it with friends, the link will be available in 24 to 48 hours. And so you'll be able to do that. So thanks again to everybody who was on the call, and enjoy the rest of your day.
And that will conclude today's conference call. Thank you, everyone, for your participation. You may now disconnect.